everyone, welcome back to our YouTube channel, Becoming a ROS Developer, here at The Construct. My name is Rodrigo, and today we have one of our students, Neil, who wants to present his project for our course, ROS Basics in 5 days for C++. So this is a project that is implemented on a real robot. So that's what we're going to be seeing here today. So hello, Neil, how are you?
I'm good. Hope you're doing fine as well.
I'm doing well. Thank you. So whenever you want, you can start sharing your screen and tell us how you have solved your project.
Yeah.
Great, we can see your screen now.
Um, I'll start the main program. Okay, I think I need. Okay. Oh. Okay. So now this project is basically divided into three parts. The first thing that the robot does
Mm-hmm.
is it looks for the wall right next to it so that it can follow it. So first it will turn towards the wall, and the lidar beam that is at the front will first point towards the wall, and then it will travel closer towards the wall, so such that the robot is only 0.3 meters away from the wall, and then it turns again, and then it initiates the wall follower motion. So right now, currently, it is following the wall follower motion where if the robot is further than zero point 0.3 meters away from the wall, then it will move towards the wall. And if it is if it is less than 0.2 meters from the wall, then it will move away from the wall to maintain like a straight line and follow the wall properly. With that, with the help of an action server, we are also basically calculating the distance that is traveled with the help of odometry messages. So you can see that here it keeps saying distance traveled 2.6,
Right.
and it keeps updating as it travels. So the objective of this robot is also to finish one lap around the circuit, and it stops when it is around less than zero point 0.5 meters away from its starting point, or it has finished around around 6 meters of its travel. That is when it knows that it has finished one lap. So here you'll see that, okay, so by the time it reaches this position, which is from where it starts, around that area it will then stop.
Mm-hmm.
And when the robot stops, it will then also send uh, a list of all the odometry points that basically the robot has traversed, and provides us in the form of a list. So you should be seeing that anytime now. Yes.
Right. Yeah.
So the robot has stopped now, and it has provided us a list of all the points that it has traveled, which is basically sent to the action message as a list of order.
Perfect.
So all the points are covered here. I'll share my code with you and
Yes, please.
stepwise show you how I approach the problem.
Yeah.
Yes. So we'll start with the wall finder since this is the first thing that the robot does. So we've used a service server here so that the robot can find the wall. Then once it selects the wall, then it aligns itself parallelly to the wall. So initially we use a service server, and to make this possible, we need uh, to create a subscriber for laser messages from sensor messages.
Mm-hmm.
So here I have I have implemented reentrant here, but I think okay, yes. So I've implemented reentrant callbacks here, reentrant callback group.
Mm-hmm.
So okay, so this is the first part where it turns towards a wall. So once the robot knows that the point that is shortest towards a wall falls within 362 and 357, it knows that the front point is facing the wall. So that is when it stops and then it moves to the next point, which is basically parallel to wall, which is approach the wall. So if the robot is uh, further away from the wall than zero point 0.3 meters, then it travels closer to the wall so that it reaches the zero point 0.3 meters point, and then it turns parallel away from the wall, such that um, the right side of the lidar scan is the shortest. So then here the range is from 200 to 220, and then after that I publish the stop sign and then it stops. So after this we go to the wall following code. Here wall following, the main logic is quite simple. I basically, for the right hand side, I use 180 as the index position for the scan that I need, and 359 is for the front position of the scan that I need. So with this, considering how further away or closer to the wall the robot is, it basically changes its direction of movement. So it either goes towards the wall, away from the wall, or goes straight if it is between 0.3 meters and 0.2 meters. So while this process is going on, we also use an action server to record the odometry points, and that is done with the help of an action server in this source code. So here we use this action server, and we here we get the position points from nav messages for odometry,
Mm-hmm.
and this is the logic of calculating the distance that is traveled. So there are two things that are done. Is one is the distance that is being traveled, and also simultaneously it is calculating what is the distance from the starting point. So both those aspects are basically considered, and considering both those aspects, once both these points are satisfied, then the lab status turns true, and then that breaks the loop. So once that is done, then the robot basically stops, and odom record is then sent to a list of odoms, and odom record is basically capturing all the points that the robot is traveling. This The action client for the action server from odom underscore recorder is in wall following. It is over here. This is the odom uh, action client.
Mm-hmm.
Here the action client is initialized. The goal is basically there's no goal here as such, except yes. So the feedback that is constantly being given is the distance that is being traveled. So as the robot is traveling over here, you get the feedback of the robot, and then this is basically to give the result and all the odometry points. This is the format of how the points are printed, and that is all.
Awesome.
And this is the initialization of the service server.
Right. And that completes the whole
Yes,
movement, right?
yes, correct.
Awesome. Congratulations. Is that your whole presentation,
Yes, yes, this
Neil?
is my whole presentation.
Yeah.
Yeah,
All right. Do you mind stopping sharing your screen just to
yeah.
see you? All right. Nice. Congratulations, Neil. Very nice. Very straightforward. Um,
Thank you.
and also, we saw it on the real robot. It worked right away, so that's always nice to see. I really liked how you first of all structure your code in classes, and I really liked how you did functions like, for example, in the service server, you did each, get parallel to the wall, and you did the function, and then afterwards you do while this is not complete, you perform the action. Just keeps it really neat, really easy to understand, um, your code readability wise. And in terms of question, I have a couple. Could you please explain us why you need a? You talked about a re-entrant callback group. Why do you need that in this case of ROS 2 and C++ in
So
these
in Wall
sections?
Finder, what I noticed was that without using reentrant callback, I was not able to keep getting the updated version of the laser point. So it would just get stuck at one, because even laser subscription is also working simultaneously. So with the help of reentrant callback, basically both those processes can traverse simultaneously. So that is why then uh, I have used it in my Wall Finder
Right. It's
code.
so you can run your callbacks asynchronously, and not have that issue of blocking
Yes, correct.
the callbacks. Uh, and I mean, the only other question I had for you is, so why do you? I saw in your code that you do separate some public attributes and private attributes of your class. How do you determine that process?
Basically, I haven't given that much thought. I just used while I was going through the course, the format of the code
Right.
was what I was following. So I
Mm-hmm.
had that as a blueprint that all my the service servers or the clients that I'm initializing will always be in public,
Right.
while the rest will be in private.
So yes, so the reason is the public other classes can utilize these variables, in the public only members of that class only, and it's
Okay, yes.
basically a way to keep it organized and not share unnecessary resources with other programs, and just keep it as efficient as possible, basically. But that's a good idea to always use a footprint, and then eventually you'll notice that, oh, if I change this to over here, nothing will change, right? But once you
Yes.
start getting into execution times and all these things that you might really need to get into, that's when it comes into play. uh,
Because when we ran the same code even with Python, we didn't have any of these demarcations as such, that
no,
this
but
is
you
public,
can
this is
still
private.
do it. You can still declare public or private variables in your class, um, but it will still work. It's just a matter of uh, organizing and deciding
Okay,
what goes where, and that's it. So, anyways, Neil, very very nice presentation. I just want to congratulate you again, uh,
okay,
great job. And I hope to see you around for the next presentation you might have planning with us. All right. Well, that's it for us, guys. So make sure you hear what Neil did, and if you're doing our course ROS 2 Basics in C++, um, make sure you do the project presentation and come present it with us, so you can obtain a certificate like Neil has here. So thank you again one more time, Neil, and we hope to see you again soon. All right, guys. Bye bye, everyone. All right.